Welcome to the Beginner's Guide to Real-World React. I'm Rob Kendall and I'll be your instructor throughout this course. Let's learn a little bit more about what the course will cover and what topics you'll learn. The Beginner's Guide to Real-World React will teach you how to successfully build web applications with modern front-end techniques using the React.js library. But why this course? React.js, or simply React, is a popular UI library that was developed by Facebook and first published in May of 2013. It allows for a modular and declarative approach to building user interfaces for web-based applications. It has grown very popular over the past few years and is one of the most sought-after libraries to learn and use by new and upcoming developers. However, React on its own is only one piece of the puzzle and doesn't out of the box cater for some of the missing pieces of common front-end development. Pieces such as connecting to an API or external data source and retrieving data to power your app, navigating around your app to different pages or areas, and managing the state of your application's data at a higher level, i.e. outside of components. The problem is these missing pieces are vital parts of any modern web application, as well as any realistic development scenario. It's key to understand both their concepts and how to approach them in React development. Many tutorials only cover one aspect of these and don't bring them together in a realistic setting. On completion of the Beginner's Guide to Real-World React, you will not only have knowledge of modern React development, but also the skills required to build real-world apps that talk to real data. You don't have to be a coding guru or have years of experience, as this course is designed for beginners. However, you should be familiar with the basics of front-end development, including HTML, CSS, and JavaScript. It would be helpful to have an understanding of basic concepts around RESTful APIs and how to interact with them, but it's not essential. In the Beginner's Guide to Real-World React, you'll join me on a deep dive into core React concepts. As you progress throughout this course, you will learn more about how React works, how you can use it to build complex web applications, and how to combine it with third-party libraries and frameworks to join the dots. You'll gain a detailed understanding of how you might use React in a real-world setting. In part 1 of the course, we'll take an end-to-end approach to React. We'll start with taking a look at the library itself and the problems it solves, before moving on to topics such as hooks and handling data from an API. Finally, we'll talk about how to build and deploy an application to a popular service such as Netlify. Included in the introductory part of the course are the following modules. Module 1, this very introduction. Module 2, React.js, an introduction to React, a modern UI library. Module 3, React hooks, what they are and how to use them. Module 4, fetching data, using APIs in your code and popular helper libraries such as Axios. And Module 5, deploying your first app, using Netlify to deploy our app to the public. In the extended course part 2, we'll cover similar topics to the first, but take a deeper dive into them and look at some of the challenges we face as React developers and how to overcome them. We'll also learn about navigating around our application and managing state across our application using Redux, a common stumbling block for aspiring React developers. The outline for part 2 of the course includes the following modules. In Module 6, Thinking in React, structuring your projects, breaking functionality into components. Module 7, React Hooks Deep Dive. Learn what each hook does and how to use them. Module 8, Navigation in Complex Apps. Moving users around different areas of your application. Module 9, State Management in Complex Apps. Using Redux and use reducer hooks to manage app state. And finally, in Module 10, the Dinosaur Search app, putting it all together by building our very own application. I'm Rob Kendall, a front-end engineer, podcast host and coding mentor. I started life as a full-stack developer, but I've been largely focused on front-end development throughout my career, which spans about 15 years or so. I've been using React for quite a while now and love its modular approach, simple, declarative nature, and how quickly it enables you to produce great-looking, functional UIs in no time at all. It really is one of my favourite frameworks to use. That said, as much as I love it, I see a lot of developers who are new to React struggling with the same concepts and hitting their heads against the same issues as they try to adopt it. Issues like, how do we navigate around our application? What is Redux? I just don't get it. How do we move data between parent and child components and back again? What about APIs? How do we talk to those? And many more missing puzzle pieces that I just don't think a lot of resources take the time to cover and help join the dots. That's why I wanted to pull all that JavaScript and React knowledge out of my head and into this course to help those new to React, just like my students, to overcome the common pitfalls. Finding out more about me. I'm a very active member of the development community on GitHub and Twitter, and I'd love to connect with you. If you'd like to know more about me and take a look at my other helpful resources, you can find the links below in the course materials. You can find me on Twitter at KendallMintCode, and you can find me on GitHub at BPK68. You can also find me doing mentoring on Coding Coach at codingcoach.io. You can also email me on me@robkendall.co.uk. I love to hear from people taking the course. My acknowledgements. First and foremost, I'd like to thank my beautiful and supportive wife and my beautiful daughter for all their help, support and patience, even if it's just letting me go to my little recording room to do these lessons, not to mention they're putting up with my many grumbles and frustrations when things don't work out as they should. I'd also like to thank Nate and Melissa, as well as the whole team at Newline, for giving me the opportunity to be able to share my knowledge with a wider audience and produce this course. Finally, I'd like to thank all my students and the wonderful tech community on Twitter, from whom I've learnt so much. They teach me new things every day, and I wouldn't be without them. Conventions and helpful links. Whilst this course is ideal for React beginners, we're going to assume that you're familiar with the fundamentals of front-end development, namely JavaScript, CSS and HTML, as well as setting up basic projects for development. We're going to be using a few other conventions and approaches during this course, especially when it comes to the practical portions. Those conventions will include building our examples and apps using modern ES6 flavoured JavaScript. For React, we'll be making liberal use of best practices such as employing hooks where necessary, and developing using functional components over the traditional class-based ones. But don't worry, this is explained in the early modules of the course. We're going to be using VS Code for our code editor, Babel.js for transpiling our code. You don't have to worry about this though. We'll be using Create React App as a starter project for our practical examples, where appropriate. We're preferring Yarn over NPM to install dependencies and run our examples, and we're applying styles and HTML elements from the Bulma CSS framework. Editing code. As mentioned, we'll be using VS Code exclusively throughout this course, but if you want to use an alternative, the examples will work just fine. Some popular code editors include Atom IDE from GitHub, Sublime Text, and WebStorm. Other useful links. To follow on from the list of conventions we've discussed, you'll find it useful to take a look at some of these services, platforms and frameworks we'll be using throughout this course. Netlify, a hosting platform for building and deploying static sites and applications, Bulma CSS, a lightweight CSS framework for building rapid UI prototypes, the React.js official documentation, which is the official documentation of the React library from Facebook themselves, Create React App, a great starter project for rapid React development, and VS Code, a free code editor or integrated development environment, or IDE, from Microsoft. Module 2, React, a modern UI library. As you've taken the excellent decision to access this course, you must have at least a good level of curiosity about React and want to know more. But what exactly is React, and why is it a powerful tool in building modern user interfaces? Let's start by looking at React's own definition from the official React.js website. React is a declarative, efficient and flexible JavaScript library for building user interfaces. It lets you compose complex UIs from small and isolated pieces of code called components. So React allows us to break down complex user interfaces into smaller bite-sized pieces of functionality that operate on their own, managing their own state, given some kind of input data, you'll see referred to as props. These smaller components can be brought together as building blocks for larger, more complex user interfaces that interact via passed-in data and events. Components are usually written in a mixture of JavaScript and HTML, which is blended into files that commonly carry a .jsx file type, although this isn't strictly necessary. React is known for being very declarative in nature. To add some clarity to this, when React is described as declarative, it means that we can largely tell React what we want it to do or display without having to worry about how this will be achieved. As an example, if we were to update some text and colour on a page using plain JavaScript, it would look something like this, which is an imperative way. However, by using React in the above example can be displayed in a declarative way. You can see that the second example we only have to describe our desired final state of the UI without the concern of physically walking through each change in the UI that we want to make. The other nice thing about React is that it uses the adaptive approach, so inside your websites and applications you can use as much or as little of React as you wish to suit your needs. React remains one of the most popular JavaScript libraries for building robust user interfaces today, and more people are keen to learn and adopt it into their development toolbox. But what skills do you need for React development? Whilst we discussed some of the requirements for this course right at the beginning, such as the need to have a grasp of JavaScript and some front-end technologies, I think it's worth answering a common question I see raised a lot in the community. When is the right time to learn React, and should I learn JavaScript first? It's a very common concern to have, and it can be a bit of a minefield for beginners to know where to start. Should you learn JavaScript first? How much JavaScript do you need to know before picking up a framework or library such as React? Questions like these. Hopefully I can dispel some of the myths and clear up some of the confusion around these questions. At its core, JavaScript, like much comparable libraries such as Vue.js, is mainly JavaScript. There are a few conventions and approaches and syntax that are unique to React, but the vast majority of what you will produce will be JavaScript. Within that JavaScript, you'll write HTML-like blocks referred to as JSX, and whilst not strictly HTML, you can think of it as such because it's almost identical to what you would write in a standard .html file. Let's look at an example. So the first lines are standard JavaScript import statements. We include React because it needs to be in scope to use it, and then we import a component called title. Next, we create a functional component, but a functional component is just that, a function. Granted, we're using the arrow function syntax to write it, but you can see that there's nothing fancy or complex about it. The main Reacty part comes when we look at what our component returns, which is JSX. It looks like HTML, and to a degree it is. Certainly from a declaration point of view, there's not much difference. However, there are a few subtle differences that are unique to React. For example, the title line, where we reference our imported component, isn't a native HTML element. This is a component tag in the JSX that React knows to interpret as, please load in my component called title. Secondly, where we call our full name method, getFullName, again this wouldn't work in standard HTML. The method wouldn't be called, rather we'd just get the string, getFullName, with curly braces, output to the browser. So to answer the original question, it really depends on the individual. Personally, I feel like it's much easier and preferable to get a solid grounding in the fundamentals of JavaScript, HTML and CSS before adopting a library such as React. That said, since the primary content you'll be producing in React is just JavaScript, you can jump straight into React too. Lesson 2. Comparisons with similar frameworks. There are many JavaScript libraries, frameworks, tools, projects and platforms out there that help solve developers' problems, help them to build user interfaces and ship excellent products faster. When it comes to the building user interfaces part, the most popular libraries out there are Angular, Vue.js and React.js. Much like React, both Vue and Angular are concerned with empowering developers to build complex user interfaces in a modular way, breaking down parts of those interfaces into component parts. Look at these search trends from late 2017 to mid-2020. You can see React is the blue line, Angular is yellow and Vue is red. Looking at this search data from Google Trends, you can see that Vue has been steadily gaining interest over the past 2 years. React has increased dramatically whilst Angular has actually declined over the same time frame. Vue.js. Vue.js came onto the scene around 2014 and was developed by a former Google employee called Evan You. Vue is a progressive JavaScript framework similar to React and has a rich ecosystem of additional libraries and plugins to enable additional functionality. Some of the benefits include empowered HTML. Vue has a lot of crossover with Angular in the way that it decorates HTML blocks within its components. Detailed documentation. One of the best features of Vue is the hugely detailed and informative documentation that helps developers at either end of the experience scale get up and running quickly. Ease of integration. Whether you're building a single page application, or SPA, or more complex application, Vue's smaller interactive parts mean it can be integrated into existing infrastructure without affecting the wider system. Large scaling. Vue can be used to develop pretty large reusable templates to power very complex apps. Small code footprint. Vue weighs in at about 20 kilobytes, keeping its size small but also aiding in increasing its speed and performance. It also has a small learning curve. Some of the drawbacks to Vue include lack of support and resources. Whilst rising in interest and boasting a loyal and growing community, Vue has the smallest market share and so naturally has limited resources and solutions out there for budding developers or those seeking answers. Angular, formerly AngularJS, which is a very different beast, is a fully fledged framework released back in 2009. It boasts a very mature framework that handles everything you need to build rich, data-driven user interfaces right out of the box. It offers an MVVM, Model View, View Model approach to development structure that separates out the working parts into their respective areas of responsibility. Some of the benefits of Angular include this MVVM structure. This allows developers to work in the same area of the app without stepping on colleagues' toes. However, the MVVM approach is not as intuitive to those starting out or to those unfamiliar with this particular project structure. Two-way data binding. This enables singular behavior within the app, reducing the risk for errors. Dependency injection of the required features that the current components depend on. Deep coupling with TypeScript, including excellent TypeScript support. Very detailed documentation and guides. It also has a mature ecosystem. Similar to the documentation, Angular is widely used and has a large ecosystem of resources, guides, help and advice for just about any situation you'll come across. Opinionated approach, even down to the structure and architecture to make sure your project can scale well. Some of the drawbacks to Angular: it's very complex and has an equally steep learning curve, which is a big barrier to entry, especially for new developers. Migration is often a problem when moving from older versions to new, and a deep coupling with TypeScript. Yes, this is also a benefit, but TypeScript is not widely adopted by new developers and adds yet another few degrees to an already steep learning curve. But which one is best? This is really a duplicitous question, as it pits each framework against one another, and it really boils down to opinions and preference. There are many solid reasons to choose any of these three frameworks, or indeed not at all. Remember that any library, framework, platform, language, design, pattern, whatever, they're all just tools. At the end of the day, you wouldn't use a hammer to unscrew a bolt, and sometimes it's about finding the right tool for the job. When you have a choice of hammers, it can be as simple as "I prefer this one over that one," and it's just as easy to write bad code with a good library. That said, we're here to become React Jedis, so let's choose React and keep going. Lesson 3. React Drawbacks. React is not very opinionated compared to some of its alternatives, which can be a blessing or a curse depending on your outlook, and is primarily focused on rendering data into the DOM. However, this can be a double-edged sword. On the one hand, it's relatively lightweight and easy to learn the basics to get going quickly. On the other hand, by being so DOM-focused, we are missing some of the other vital puzzle pieces involved in web app development. For example, if you want users to navigate around your application or manage your application's state at a broader level, you're going to need to use additional third-party libraries such as Redux and React Router. A common complaint with React is its learning curve. Whilst not as steep as a framework such as Angular, it does not have the simplest learning curve and can leave some aspiring React developers stumped with particular mechanisms such as updating state and passing data via the props object. Another issue is with the lack of strong opinions within React. React is known as an unopinionated library. This means that whilst it might come with some nuances and specific syntax that it prefers, it doesn't force a particular way of working on the developer, nor does it bring with it a raft of specific ways to implement common tropes, such as navigation or talking to an API. For experienced developers or teams using agreed development standards, this might be less of a problem. However, for newcomers to both React and front-end development in general, being let loose with a React library without a clear set of best practices or other guidelines can lead to poor coding standards, code quality issues, and frustration as you receive conflicting advice on how best to approach component development. Don't worry though, over the lessons in this course we'll explore some of the most popular and most common approaches to fill in the blanks that React leaves us with out of the box. Lesson 4, our very first React app, the Greeting App. In this very first coding example, we'll be building a really simple React app that accepts a name from our user and displays it as part of a nice welcome message. Let's take a look at what we'll be building. This is the finished example we'll be building before we refactor it. Once it's running, you'll see we have a simple title to welcome the user to the app and a set of instructions to invite the user to enter their name and click the update button. If I enter my details and hit the update button, you'll see that the text "we haven't been introduced" will be replaced with my name, Rob Kendall. It's a really straightforward demo that isn't too complex, but it highlights a number of key React concepts that we'll be building upon throughout the course. In the next lesson, we'll be breaking down the greeting app into its component parts and taking a peek under the hood to see how everything pins together. Hello and welcome to our very first React demo as part of the Beginner's Guide to Real-World React course. The first real example we're going to build is a really simple greeting app that's going to accept a name from an input box and output it back to the user as part of a welcoming message. So the first thing we need to do is to add the parcel bundler. Now you can just use React by loading it using a script tag from a package repository like unpackage. However, what you'll find with most real-life React projects is that we'll be adding React libraries over npm and usually some sort of code bundler such as Webpack or even the Create React App starter project, which uses Webpack under the hood. We're going to do something similar to get you familiar with using a common means to build and run a React project, and for this we're going to use Parcel.js. Parcel.js is a really simple code bundler that's very much like Webpack but without a lot of the complex configuration and setup. In its own words, Parcel.js is a blazing fast, zero config web application bundler. So you can see I've got the Parcel.js website open, which you can find by navigating to parceljs.org, and we're going to head over to the Getting Started section. We'll need to install it globally onto our machine, and you can do that by using the commands in the course documentation. It should be npm i-g parcel-bundler, or if you're using yarn-global add parcel-bundler, and you can see those here. Once you've done that, we'll close this window up and we'll open a brand new project in VS Code. So I've got a shiny new empty folder that I've opened in VS Code. I've got a git ignore file and a readme in here because I've got this connected with a git repository, but we're not going to use those files and you can ignore them for now. Because we're using Parcel, we don't need to do any configuration to make it work, but we do need to add React to our project. So you can see I'm in VS Code. If you open up the terminal in VS Code, which you can find by clicking down here, this will open up this kind of terminal and output bin. If we click on the terminal, you'll see that it opens up in the current working directory of our project. From here, we're going to need to do 3 steps to get our project up and running with everything we need. Number 1, we need to initialize our project. 2, we need to add the React dependencies. And 3, we need to add a shortcut script to build and run our code. So the first thing we're going to do is initialize our project. The first step to initialize our project is to get a package.json file up and running. To do that, we're going to run the command yarn init and -y. We add the -y flag, which will automatically answer yes to all the initialization questions, such as who's the author, what's the license, and those sort of questions that we don't really care about for our quick example. And you can see it's created us a package.json file here. So step 2, we need to add the React dependencies. So now we're going to add React to the project. There's 2 packages we need, that is React and React DOM. React is the star of the show and includes the core React library. React DOM is a secondary package that is responsible for rendering our components to the DOM in the browser. Back in our terminal, we need to type the following command to add both packages to the project. That's yarn add React and React-DOM. Yarn is very well cached and very fast, so both of these packages should be added to the project in no time at all. And you can see, there we go, we've got React and React DOM. So the final step is to add the scripts for building and running the code. This is the final part of the setup, and it involves the package.json file that I've got open here. Notice the React and React DOM dependencies are in there. Now, once we've built our app, we need to call Parcel to bundle everything up and run it. It's not a huge chore, but we can add a simple shortcut to help us out. In our package.json file, we need to add a new property, scripts. And we need to add a new command property under this, and we'll call it start. Now, inside this start build command, we'll need to add the following instructions: parcel index.html-open, and we'll save that file. So the new part of the package.json file should look like this. We've added a scripts tag, and then we've added a start command with the command parcel index.html-open. What we've just written there is a terminal shortcut that will allow us to type yarn start and have our parcel command open our starting file, and the -open flag tells Parcel to open the running code in a browser once the files have been compiled and Parcel's development server is up and running. And you notice I've made a slight mistake there. We need to have 2 dashes before the open. Parcel works by giving it an entry point. In this case, ours is index.html, which we'll be building next. And from there, Parcel works out which files it needs to include in the bundle based on your imports and references. So, coding the project files. Now we're on to the exciting part, building out our example. Now, for smaller projects like this, I like to just start by creating all the files we need and filling them in as we go along. For our greeting app, we're going to need to create 4 files, so let's create them now. The first thing we'll need is a styles.css file. We'll just have some basic styles in here to make our app look just slightly more interesting than the out-of-the-box HTML. We need our parcel starting point, index.html. This is going to be our first entry point that Parcel is going to look for to render our app. As a starting point for the JavaScript, we need index.js. And finally, our main React component, which we'll call app.js. This is our main entry point for the React side of things. Once we have the files created, let's start filling them out, and we'll start with our styles.css file. Our styles file isn't exactly essential at this point, but it's nice to have a few basic styles available to improve the built-in look and feel that browsers give us by default. So you can see that I'm just going to copy in some really simple styles that just affect the body and the font size and the line height. Later on, we'll be adding an input and a button to our app, so I've added some nice styles in there for those as well. Give that a save, and we'll move on to our entry point, our index.html file. The next thing we want to do is add some HTML into our index.html file. I'm using Emmet that comes with VS Code because it allows me to just type the name of the HTML element like this rather than having to type it all out by hand. So it's a nice little time saver. So we'll add our HTML tag first. Inside that, we're going to add a head tag, and within that, we'll add a title tag. And I'm just going to give it a title of my first React example. We'll also need a body tag, so we'll get that added. And within the body tag, we need two things: some kind of element to render our React output into, and a script tag that references our JavaScript entry point index.js, which we'll create once we're done here. So the first one, I'm going to add a main element, and I'm going to give it an ID of output, and that'll get filled in for us. Finally, I'll add the script tag, and we'll just give that a source reference of our index.js file. So what happens here is that when Parcel runs, it looks in this first file for any script tags. When it finds the one pointing to index.js, it looks in there to see what other JavaScript files it needs to import and chain together to bundle up into our working app. With that done, we'll save the file and move on to the main JavaScript entry point index.js. Inside our index.js files where the magic happens. It's the first place that we really set up our React app to load and inject it into our HTML page. This is going to be quite a small file where we're going to add our first piece of React code. We'll need to do a few things inside this file. We need to import React, import our main app component, the starting point for our React app, and we need to use React DOM to render the app to the browser. First off, we need to import our two React packages, React and React DOM. So let's do that now. So we'll import React from React and import React DOM from React DOM. It's important to note that whenever you're doing anything with React, you must import it at the top of the file. This is what's known as bringing React into scope. For this, we also need the React DOM package, which is responsible for rendering our React code to the browser. Finally, we'll import our app component, which will look after greeting the user. This is import app from app. Now we have all of our imports. We need to make sure our app gets rendered to the browser, and to do that, we're going to call the render method from the React DOM package that we imported. So we're going to use React DOM.render. So React DOM render accepts two arguments: the component that you want to render, so for us that's app, and where you want to render it. So in this case, the HTML element from the index.html file. To add our app component into the React DOM render, we'll first get our first glimpse of the JSX, React's XML-like syntax. So we'll do that with app, like this. It looks very similar to XML or HTML, and indeed later on we'll be adding the paragraph tags and input elements into our components, but it's important to know the difference. What we're using here is JSX, which is a proprietary React syntax. For the second part, I'm just going to use the document.query selector to find the main element in our index.html file. We gave it an ID of output, so we'll use that here to find it. Save that file, and that's us done. Onto our app component. So notice the name of the file has been capitalized to app.js with a capital A. This isn't 100% necessary, but it's a convention used among React projects to capitalize any component file names. So the last piece of the puzzle for us is to build out our app component to actually make something happen and greet our user. As we already discussed, if we're using React, we need to have React in scope, so we'll import React at the top of the file. So we'll import React from React. Now what I like to do when we've done this is just outline the basics of the component and then export that component so it can be used in another file or another component. That'll look like this. So we will have class, give the name of our component as app, and extends react.component to do implement component contents, and then we export default app. For now, we're going to use the class-based component, which is an older, less preferable means to build the components. However, you'll see some of them out in the wild, so it's useful to take a look at how they're built. For future lessons, we'll be using the more modern functional components with React hooks, which look a bit different. For class-based components, we need to extend React's component class. We can do that by typing the extends keyword after our class declaration and extending the React.component class in there. To make this look a little neater, we can import the component class as part of our React import at the top of the file. To do that, we'll add it as a named import, like so. By doing that, we can replace the React.component part with just component. Finally, we want to add a default export for this component at the bottom, which is just app. We'll add this right after our class declaration. We're not quite finished yet, but we've got the building blocks in there. If we run this now, nothing would happen because our component doesn't return anything. So let's add a title. All React components have to provide some sort of return, which is usually a block of JSX. With class-based components, we have to first provide a render method and then add a return statement within that render method. To get us started and to test our app, we'll just return a heading. Add a render method and a return statement within that will add a simple message using a h1 tag. So we're going to add a render method, and within that we'll add a return statement, and we'll add a heading level 1 and just type welcome to the app, just like that. Great. Right, now the fun part. Let's head over to our terminal. I'm going to clear mine. Great, so let's head over to our terminal and we'll type yarn start to start Parcel building and running our app. Parcel is going to find our index.html file, follow it up to our index.js file, and we'll load our app component, and then Parcel will bundle all that up, optimize it, and start a local development server that runs at localhost port 1234, which we can visit now. So we'll see our lovely welcome message, welcome to the app. Another nice thing about Parcel's local development server is that it hot reloads, responding to file changes on save and refreshing the browser. For example, if I change this to welcome to the jungle and saved it, you can see that it automatically hot reloads and updates it, but we'll leave it as app for now. An important thing to note about JSX is that you can only return one top level element. To highlight this, if we add a paragraph tag under here and say this is a paragraph and give that a save, we should see a nasty error message. So the error message states adjacent JSX elements must be wrapped in an enclosing tag. Did you want to use a fragment? So you can see we've got two adjacent top level elements returned in our return statements. To fix this, we need to wrap them in a div and hit save. Then when the app reloads, we'll see our message and a paragraph, and importantly, no error. However, adding an additional div is fine for our example here, but you might have situations where you don't want to add additional markup and output to the browser, and wrapping everything in a div or some sort of other element won't be sufficient. For these cases, you can use the React.fragment syntax. So we can replace our containing div element and either use React.fragment but the shorthand version is to just have an opening and closing bracket, a corresponding opening / closing bracket like that. So we save that, you can see exactly the same output. So React.fragment and the opening and closing bracket are functionally equivalent, they do the same thing, but the shorthand version just looks a little bit neater. React uses its own copy of the DOM called the virtual DOM. React handles changes to this internal copy of the DOM and the real DOM in the browser for us to keep everything in sync. Although JSX looks almost identical to the same HTML that we type into a .html file, it's important to understand that it doesn't map directly to the HTML and the eventual output to the browser. So it's time to expand our app by adding a dynamic message. In the first paragraph, we're going to return our user's name once they've typed it in. To do that, we need to modify our paragraph tag to include some executable code. So we'll edit that to say, hi there, this.state.displayName. If you did this in HTML, you'd just get a paragraph with the text, hi there, curly bracket, this.state.displayName, closing curly brace. But because we're using it in JSX, anything between the curly braces will be interpreted as executable JavaScript by React and evaluated as such. You'll also notice a call to a class property called state here. Every component has access to its own state, its own local storage as it were, where you can store values in state as well as retrieving them, which is what we're doing here. So this line, this.state.displayName, we're really saying get me the display name value out of this component state. We haven't added any state yet, so let's do that now. So within a class-based component like this, just like a regular JavaScript class, you'll want to initialize any state values in the constructor. So we'll add a constructor here. This.state, it equals an object, and we'll type in our display name property, and we'll just leave it as an empty string for now. So React automatically wires up our constructor when the component is created and passes it the properties object called props for short. You'll see this a lot when we're dealing with React. And the first thing we have to do in our constructor is call the parent class's constructor using the super method. The parent class is the component class here that we extended right at the beginning. So we're using the super method and we're passing in the props object that's passed to this app component. To add our component state property, we simply call this.state and set it to an object that contains whatever data you need. So for now, we've just added the display name property and set it to an empty string. An important thing to note about state is that it is immutable. This means that whilst it can be updated using React's setState method, we never edit it directly. The only time we ever edit it directly is inside of a constructor function. You don't have to initialize state in the constructor as we're doing here, but it's a good habit to get into so that anyone coming into the class can see what properties should be expected to exist on the state object and what their values should be. So we've got a dynamic welcome message, but we really need to allow the user to enter their name so we can greet them personally. Let's add some instructions and an input box. So we'll add an input element. And we want to add a button. We've set our input's value to another state variable, this.state.name. By doing this, we're turning it into what's known as a controlled component. HTML form elements like inputs and selects and text areas are typically uncontrolled components because they handle their own state and values. However, by letting React handle our input's value from state, it becomes a controlled component, which means that React is responsible for maintaining the state of any value that we assign to it. Since we've added a new state value reference here, let's update our component state in the constructor. So we'll add the name value and set that to an empty string. If we stop there, however, the value of the input will always be an empty string. We need a way to update the value in state whenever someone updates the text. We do that by adding an event handler to the input element, and the perfect place to do this will be as part of the onChange event. This is where we have this onChange event and we assign it to this.handleChange. So we add the onChange event to the input and add a handler function, handleChange, which we'll define now. So we'll add the handle change just before the render method. So we'll define handle change. So the handler function is a simple arrow function that accepts one argument, which is an event object that React automatically passes in for us. This is known as a synthetic event. We're calling it EVT here, but you might see it called E or event. In this function, we just need to update our state's name value with whatever text the user has entered. So to do that, we'll use React's built-in state updating method, setState. We'll call setState and we pass it an object that contains any property value pair that we want to update in state. In our case, we want to update the name property, and we want to update it with the value of our text input, which we can grab from the EVT argument using evt.target.value. In order for this to really be a true app, we'll give our users some way of triggering a greeting message update once they've updated their name in the input box. To do that, we've added this button element just under our input element with a similar event handler, but this time the event has been named onClick instead of onChange. We'll also give it some text, update name. So we're going to add another event handler underneath our handle change, and with this one we'll call handle click which matches the name that we've passed in to the onClick event on the button. So within handle click, it's very similar to onChange, and again it receives a synthetic event argument that we'll just call EVT once more. And you can see our click handler method is going to do something very similar. So we're going to set state, but this time we're going to pass in an object with the property of display name, and the value is going to be set to this.state.name. The display name value here is going to be the same as the final value they've entered in our input box, which we've already set to the state value name. That's what we'll use to update state in our handle click method. So now that we've got everything we need, let's save our app.js file and let's take a look in the browser. If we enter a name into the input box and click update name, you can see that instead of hi there and blank, we get hi there, Rob Kendall. The very last part of our greeting app is just to add a little bit of spit and polish. Remember those styles we added right at the start? Now we're going to add them by importing them just before the class component. And we do that by typing import and then simply the reference to the file. Give that a save and we'll take a look in the browser. So you can see it's not an award-winning app just yet, but you can see it already looks a little bit nicer. And last but not least, we have an initial message, hi there, which is blank, and then just nothing. We can make this a little more interesting by adding a default message, we haven't been introduced. So we'll do this by amending our initial greeting message using the logical OR statement. It sounds quite fancy, but it's really just a shorthand if statement in JavaScript that you'll see used a lot in React as a way to say evaluate both sides of the argument and return whichever is true. So we can do that here. Because our state value, this.state.displayName, is empty, which is falsy, by default, React will look at this and return the right-hand side of the argument, our default string. And that's it. We'll give it a save. You can see it's updated. So we've got hi there, we haven't been introduced. If I add my name and update name, you can see that that default string gets replaced with what I've entered in the input box. In the next lesson, we're going to refactor our app component into smaller components and introduce some React hooks. So, we've built our first app and it's looking and working great. Currently, it's using the class-based component approach, but we're going to refactor it to achieve a few things. Get used to thinking about our apps in a component modular fashion. Try our hand at breaking down a larger component into smaller ones and introduce the arguably more common functional component approach to building our React components. So at the moment we've got this large class-based component with all of the different things going on, including our event handlers here for onChange and onClick, and we've got a dynamic greeting and a title in there. It's not a very large component, but you can see how easily it could get out of hand if we add more and more features and functionality to it. It's not very modular and it's certainly not very reusable. It's good practice to analyze your components and try and break them down into smaller ones where possible and where it makes sense. This way you can encapsulate functionality into smaller working parts, which can be duplicated and used in different places throughout your app. So it's useful to have a look at larger component as a whole and then think about smaller independent parts of functionality that it contains. These smaller moving parts can be broken down into components and used elsewhere. They'll no longer need to be tied into the single larger containing component. To do that with our app component, we can look at what it's currently doing and see that there are 3 distinct functions that it performs that would be good candidates to be turned into separate components. So number 1, it displays this welcome message in a heading level 1 tag. This could have different styling applied to it in different parts of the app, or it could accept different messages on different pages, so it's a good fit to be separated out. Number 2, it displays a dynamic message to the user here, including data from our state. This greeting is quite simple and generic, and you might see it on the home page, but you might see it on an account page or on main navigation, say in an e-commerce site, to greet whomever's logged in. And number 3, it accepts an input from the user here and triggers an event on a click of a button. We're using the input and button combination here to accept a name, but it might also work on a contact form or as part of a search form, things like that. Being able to have these 2 connected elements in one place in a separate component makes it a great candidate for refactoring now. So let's have a little look at a diagram of how we can group these three separate areas of functionality into independent components: a title, greeting, and input. These child components can be imported into their parent, the app component. So let's plan out the refactor. We have an idea of the components we need to build, and now we just need a set of steps to carry out our refactoring work. So those steps might look like this. We'll create a components folder to hold our new components. We'll create 3 new components: a title, a greeting, and an input. We'll refactor the app component to use our new child component, and we'll refactor the app component a little bit more from a class-based one into a functional component. So let's do some refactoring setup. Now we have a plan, we'll need to do a quick setup before we start. Like we did in the last lesson, we'll create all of the files that we need first and fill them in as we go along, building out the components and refactoring them as we go. So first, let's add a new folder and we'll call it components. Within our components folder, we'll create 3 empty component files with the .jsx file extension, remembering to capitalize the first character in the file name. So we'll create a title and a greeting and an input. So another thing to note here is that files with the .jsx extension are specific to the React library and will typically contain familiar XML, HTML-like syntax that we've been using in the earlier chapters. However, it's important to note that this file extension is down to personal preference. JSX files can be converted into raw JavaScript by tools such as Babel.js before being run in the browser. Some people prefer to have presentational components, which are ones that just accept static data and display it, using the .jsx file extension to denote them as such. The important thing to remember here is that you can use either .js or .jsx to name your files. There's really very little difference. It just comes down to personal preference. With that taken care of, let's start moving through the files and building them out, starting with our title component. So we'll start out by repeating our mantra: React must be in scope in order to use it. So the first thing we'll do, we'll import React before we do anything else. Instead of using the class-based approach previously like we used for our app component, our title component will be our very first functional one. So we'll define the functional component just as that, a function. However, rather than define a function then set it as the default export afterwards, we can do so in one line like this. We'll say export default, and then we can create our function props and return a h1 welcome to the app, just like we've got in our app component. Now, note that this is a nice style to have for smaller, less complex components, especially if they're purely presentational like here. However, if your components start to grow or feature very complex functionality that might cause bugs, it makes sense to define your function and assign it into a variable, i.e. like a const, and then export it immediately afterwards. This is because React debugging tools struggle to identify components that are defined and exported in a single line, as we're doing here. So you can see we've got the default export, which is a function that accepts a props object and uses an implicit return, that is without the return keyword and some JSX parentheses. Because we're not doing any other logic, manipulating state, etc., we're just returning some JSX, we can use this implicit return here to make things look a little neater and remove unnecessary lines of code. And that's it, sort of. We've got a heading level 1 being returned, and we've got a fixed string in there, welcome to the app. That's fine for our greeting app, but not very reusable if we wanted to have this component on another page that said something different. So we can make this title dynamic instead of it being hard-coded to a string, and we can use our curly brace syntax again and use a value that we can pass in via the props object. So we'll replace this with props.title like this, which is great. But we can take this a step further. Because we know we're only going to be passing in a title value via props, we can reference this value directly using object destructuring, like this. We know that props will expect and be passed a property called title, so by replacing props with some curly braces, we can now start to directly name properties that we expect props to have. This, in essence, is JavaScript destructuring syntax, and it's really quite neat. So as well as replacing the props argument in our function, we also need to replace the curly braces props.title here with just title as well. What we're left with now that we're done is a really simple, small, reusable component. It can be used wherever we need across our app in different areas. It's also useful if you want to make changes to the way titles look, such as styling or size or colour, tag attributes, things like this. All those changes can be made in this one single place. The thing to remember is what we're making here is a very contrived example just to get a feel for React, but it's good to start thinking in terms of how you can use this in real-world applications as you start learning and growing and building things for yourself. This is something we're going to do further on in the course as our apps start to grow and get bigger, but for now our title component's ready to go. So let's give it a save. Moving on to the greeting component. So what we're going to tackle now is the greeting from our app component. So this line here. You can see we've got a paragraph tag and a string and display name property that we're getting from state. We can pull this out into our greeting component. So the first thing to do is start by importing React. So we'll import React from React. And again, just like our title component, we're going to do an inline default export next, along with an implicit return, because all we're doing is returning one line, which is going to be our greeting with a dynamic name value. So we'll do that like this, export default. Notice that we can also repeat the destructuring syntax here to pull the name value from props. The difference this time is we're going to add a default value for the name just in case it's not set. So we can happily do the same as we had in our app. We can do name or, and then put our message in there using the logical OR operator, but I find doing it up here is a little bit neater. So I'll leave you to choose which way you'd like to do it, as both produce the same result. But this is going to be our greeting component complete. So the penultimate thing to do is to build out our input and button component. This one's going to be slightly larger, but still not very complex. We're going to import React at the start of the component, but this time we're going to add a little extra named import, useState. Because our input element relies on the app component's state to keep track of its value, we need to use state in our new input component. The problem is the input component is a stateless functional component, not a class-based one. In order for us to use some form of state in a functional component, we need to use a feature of React called hooks. In our case, to access state from a functional component, we use the useState hooks. Now, hooks were introduced as part of React version 16.8, and they allow access to state and other React features without writing a class. Don't worry about it for now. We're going to be covering hooks in greater detail in the next module, including useState, but for now let's focus on getting the components built as you follow along and being familiar with the useState syntax for accessing state in a functional component. So now we've imported React, we'll define our input component and export it right afterwards, making sure to copy in the input and button elements for our app component. So we'll define our component as input and then we'll pass it props. And then immediately afterwards we'll do export default and then export our input component. Notice how we've capitalized our constant variable here, input. This is a convention, not a rule, but since we're creating a component, it's best practice to capitalize components' names. So now we've got to update the input element. Now remember from the first lesson, we can't just have an input and a button side by side like this within the return statement. So to avoid that, notice how I've wrapped it in that familiar React fragment that we talked about in the first lesson. The previous two components, greeting and title, both used an implicit return because they didn't have any logic to deal with. They just returned their JSX elements. Our input component, however, needs a little more, mainly around setting values using the useState hook. Because of this, you can see that we've explicitly defined the return statement here that contains our desired JSX output, i.e. the input and button elements. Notice the difference from the app component, which has to define a render method and then a return statement. You'll also see because the input component is a function, we don't need to define a constructor nor call a parent class using the super method. So what we've got here is good looking so far, but we need to make a couple of tweaks in order for it to work. So looking at the input element in our return statement, we're still referencing a state value here and a handle change event, both from our app component. Neither of these two things work because of the differences between our app component, which is class-based, and our input component, which is functional. Luckily for us, we can replace both things using the useState hook. First, let's define the hook at the top of our component outside of the return method, and then start using it in the input method. So we'll type a const, type an array bracket, and then we call the useState hook and pass it an empty string like this. So it looks a little strange if you're not used to seeing this sort of syntax, but the useState hook works like this. Number one, useState is a method that React provides as part of its core library. You call it passing in whatever default value you want the particular item in state to represent. So for example, we're using it here, we're defining useState, and then we're calling it with an empty string, which will set the value in state to that empty string. The method returns an array with two items. So the first item represents the value held in state, and the second item is a method that can be used to update the first item in state. You can use the array destructuring syntax here in JavaScript to access both of these items. So in our component, you can see that we're defining a const, which is a destructed array. This array contains two items. The first is going to be the value held in state, so name, and we call it name, but remember this is the title that we're going to be giving it. You could call it anything, but we call it name as it's meaningful to us right now. The second item will be the method that useState provides us to update the first value, the value held in state. So again, you can call this whatever you like, but the sensible convention is to call it the same as the name of the state value prefixed with the word set. So for us, this means we'll call it setName. Now, wherever we want to update the value of name in state, we simply call the setName method, passing in a new value. Looking back at our input method down here, we're ready to update its attributes to use this new state hook variable's name and setName. So all we have to do is remove this.state from the start of it, and we'll change this to EVT, and we call setName with evt.target.value. So the first edit is to change the location of our state data for the value attribute on the input element. We can change where it was this.state.name to remove the reference to this.state because that only applies to a class. The value is now going to be stored in this name variable here, so we'll just refer to it as name. The next thing to do is to replace the call to the missing this.handle change in here on the onChange event, since we're going to be using the setName method that we got from our useState hook. So we can actually simplify how we do this in line right here in the onChange event. We don't need a separate function to be defined. So using a simple inline arrow function here, we simply call the setName directly, and we use the same evt.target.value to reference the underlying value of the input element from the event, the evt argument, that we passed in the onChange event. Now, notice that here is an important point. You might be tempted to just call setName directly without an arrow function, like this whole thing. However, events like the onChange event require that you pass them a function so that it can be called when the time comes. By writing out the function directly, so if we just had setName here, and passing it arguments, you're effectively invoking that function right away. Now that creates a problem, especially when you're updating state values, because it causes React to render the component again, which in turn calls the function again, which calls the render again, resulting in an infinite loop. But that's all there is to it. So next, it's time to update our button element. So the button element presents an interesting situation. We need to trigger an update to the display name property. However, that particular piece of state lives in the app component up here. So how can we update state from another component? Well, in the same way that we can pass data down to child components via the props object, we can send data back up using events and event handlers. To do this, we can update our button element with similar looking anonymous arrow function that we used for the input element. But this time, instead of calling the function on the app components class as we did previously using this.handleClick, we'll call the same function but from our props object, we'll pass in the up-to-date value for name from our local state data, and that's the button element finished. So we'll define an arrow function, and we'll say props.handleClick, and we'll pass in the name value from state there. So now we need to update the app component. With our 3 new components complete, it's time to edit the app component so we can actually use them. So first things first, let's import our new component at the top of the app component. So we'll import title from the folder components, title, then we'll import the greeting, and finally we'll import input from components input. So next we're going to replace the existing JSX with our imported components. Our new return statement should look a lot simpler when we're done. So we'll replace this. We'll take out this title, and we're going to replace this heading 1 with our title component. We're going to replace this line with our greeting. We're going to add just a little line of instructions. And then we can replace our input and button elements with our input component. Great. So if you look at the title component, you'll see that we've added an attribute of title and passed in the original greeting, welcome to the app. This means when our title component calls props.title or references it like we have in the destructuring, welcome to the app is what it'll receive. We do the same thing with our greeting component, but this time we're passing a name attribute, the display name value from state, using this.state.displayName. And finally, in our input component here, we're adding another attribute of handleClick, which you'll remember needs to be a function so the input component can call it via props. So there are a few more changes to make to the app component before everything's complete. We can remove the handle change event because it's no longer needed. It's handled within the input component. We can remove the name property from the state up here because again that's handled in our input component, and we need to update the handleClick event here to reference the new name value that's passed to it. So first things first, let's locate the handle change event and just remove it altogether. Next, we'll update the state object to remove the name property. So we'll just delete that property out altogether. And then lastly, we'll update the handleClick event to reference the name value that's passed to it from the input component. So currently, it's referencing this EVT object here, which is, remember, the synthetic event object that's passed to it but automatically via React. So we can change this to name, which will now be a new string value that's passed in when this event is called from within the input component. Then in the setState method, where we're currently passing the property display name, the value of this.state.name that we've just deleted, we can update this to use the name argument that is supplied to us from the input component. So let's give this a save, and then let's run this. So you can see not much has changed on the front, except now if we type my name and click update, or we type anything else in here, update name. So it doesn't look a lot different, but you can see that we've broken down that functionality into smaller moving parts in our separate components, and now the app is using those, which is great. So now we've got to refactor the app component. To round things off, we can make a couple more changes to the app component to modernize it a little and make the code a little bit more smaller and a little bit more readable. So we'll convert the app from a class-based component to a functional one. We'll replace the current state mechanism with another use of the useState hook. So the first thing to do is to convert the class-based component, the app currently is, into a functional one. It might seem a little daunting, this process, but it's quite straightforward and it gets easier to do the more you do it. There are a few main parts to achieve. Firstly, we need to replace the class keyword and general class definition up here with a function name and arguments. Next, we'll remove the constructor function altogether, which is specific to classes, abstracting any logic we need out of here. Then we'll remove this render statement and take the return statement out of it. Once this is done, we can just delete the empty render statement. And finally, we'll add the const keyword to any functions that are class properties, such as this handle click event here. So in our case, the current app component, class declaration and constructor will be replaced up here from this to const app, get the props object, and we will do const display name set display name equals use state. And because we're using use state, what we need to do is firstly remove this component component import that we're no longer using. So we can remove that, but replace it with use state that we are going to use. You'll see that we still do need to use the display name property from state, which is why we're using the use state hook. But notice the naming convention again. We'll use display name for the value in state and set display name for the name of the function that will update the display name value in state. We can also remove this entire handle click function here because we'll be replacing it with the set display name function call. Now we can replace the render method. Because the render method's only needed for class-based components, we can replace it with the entire return statement. So we can just literally get rid of the render method, and that just leaves us with a return statement. So now the final thing to do is to update our display name in state. So of course, now we've updated the display name property to use hooks, we now need to update our 2 lines in our return statement. The first isn't a very big change, but since we don't have access to a class property named this.state, we can just remove it from the greeting and reference display name directly. So we'll replace this.state.displayname with just display name. The very last thing to do is to replace the call to the non-existent this.handleClick that we passed into the input component with a direct call to the hook method setDisplayName. It will receive a name value in an argument, and we will just use the setDisplayName directly, passing it the name value. So again, to prevent an infinite loop or some other kind of issue, we've passed an inline arrow function instead here, instead of this.handleClick. It receives a name value as an argument when the input component calls this function, and we immediately call the setDisplayName function here to update the display name value in state. And that's everything done. Let's save everything and refresh the page in the browser to see it in action, and everything should look the way that it did before. The refactoring process isn't too painful, but you can see already how the app component's much smaller, much neater, and much more modular. What's more, we now have a bunch of smaller components that contain their very own logic that can be used throughout our app as it grows and starts to expand with more sections. So we'll just test it out one last time. If I type in Superman and click update, there's Superman. And you React Heroes. Well, hi there, React Heroes. Lesson 7, React Core Concepts. In this final lesson in Module 2, we're going to briefly introduce a core concept that lives right at the heart of React, and that's how to pass data around between different components. I meet a lot of students who are both new to coding or new to React, and one of the common sticking points is how to deal with data, passing it to other components and getting other data back into the original parent component. Because of the modular nature of React development, you'll generally be focused on creating small, isolated parts of functionality within your apps. You'll then build larger features or areas within the app by combining these modules or components together. Even if one component is not a logical parent of another, that component may reference another in order to build some area of functionality. The component doing the referencing can be thought of as the parent component, whilst the component being referenced can be thought of as the child component. As an example, a header is not naturally related to a shopping basket, but an e-commerce website might have a count of the current items in the shopping basket in the header somewhere. Therefore, we can say that the header component would be the parent component and the shopping basket would be the child. Of course, parents can have parents themselves and children can have children. The important thing to remember is this initial relationship, as it dictates how data flows within a React app. Without getting lost in complex topics such as Redux, which we'll be covering in a later module, data generally flows in two directions within React: down via props or up via events and event handlers. Looking at this visually, you can see that a parent component can pass data downwards to its child components via props. Similarly, child components can feed data back up to parents via event handlers, which would usually be functions passed down to them via props. Let's have a look at this quick example to illustrate data handling in action. In this simple example, we have two components, parent component and child component. In parent component, we have an array of strings that is set into state using the useState hook and assigned into the items variable. We then have a clear basket function that sets the value of our items array to an empty array. Parent component then returns an instance of the child component, passing both items and clear basket into it as props. In child component, we return a paragraph that tells the user how many items are in their shopping basket by checking the length of the items array it received via the props object from parent component, although in child component, this is received as a basket. Now, if we want to clear the basket, we can't do this in child component, so we need a means to tell parent component that we want to empty our basket. The way we pass this request up to trigger the clearing of a basket is with a function passed to child component via props. In our case, that function is clear basket, and we're passing it into child component via props under the name click handler. In child component, we attach the passed in click handler function to the onClick event of our button element. So now, when the user clicks the button, the onClick event is triggered, which calls the click handler function from props. The click handler function, which is really clear basket, is invoked in parent component and the basket is cleared. Fortunately for us, React takes care of this syncing of the dynamic data passed between components via props on our behalf, re-rendering the UI as needed. In our case, when a user clicks the button in child component, a function in parent component is triggered which clears the items array. The new items array, which is empty, is then passed down into child component again, which re-renders the output, this time displaying the new message, you have 0 items in your basket. React handles this automatically, which is pretty neat and one of the most powerful features of the React library.
Module 3, Introducing React Hooks. So hooks aren't the newest addition to the React library. In fact, they were introduced in version 16.8. The current version at the time of writing is 16.13.1. However, they've taken a little while to be more widely adopted by the community as standard practice when developing React components. In React, hooks allow developers to tap into some of the more powerful features of React, such as state and the component lifecycle, without having to write some of the more cumbersome syntax required in the more traditional class-based components. But why hooks? Well, hooks offer us several big advantages. Number one, they allow us to write smaller, more manageable components. They allow us to reuse stateful logic between components. We'll discuss that next. They reduce complexity of dealing with the React component lifecycle. They eliminate the difficulties that learning about and dealing with JavaScript classes can bring, especially around how this works and binding event handlers. We can cover these advantages with a couple of examples. So the first, reusing stateful logic. By stateful logic, we're referring to a component's state, the data stored by the component and associated logic that alter the state. Before hooks came along, state was quite rigidly bound to a particular component, and common or repeated logic wasn't easily removed into a separate space to be reused across other components. Hooks solves this problem by allowing you to grab this stateful logic and create your own hook to reuse wherever you wish, without changing your component hierarchy. Let's look at a quick example. So say we wanted to know the status of a user compared with the amount of authorized roles they had within a system. We could use something like this. But then in another component, we wanted to see a list of that user's roles, perhaps for an account page. That could look like this. As you can see, we've got a lot of shared logic between the two components. We can use a custom hook to abstract this into a shared state logic that deals with the roles list. Like this. And now we have our custom hook. We can update the examples we've just seen to use it, like this. When it comes to reducing complexity, let's take a quick look at how hooks can reduce the complexity of our components when compared to previous class-based syntax you might have seen in the past. So you can see already that whilst it's not a very complex component in terms of what it does, this is already becoming quite long and will prove more difficult to manage over time if it grows. We've got data loading happening in several places across different parts of this component's lifecycle, as well as having an extra state management work in the constructor function, not to mention the liberal use of this in reference to state and props values. But we can refactor this to use hooks, similar to how we did in the previous module. Like this. See how much smaller and more readable we've been able to make our component? We've also reduced a lot of the complexity and overhead involved in managing several lifecycle methods. But do I have to use them? No, not if you don't want to. That's one of the beauties of hooks. They're 100% completely opt-in. You can also use them alongside class-based components if you wish. Indeed, you might very well encounter a mixture of class-based components and hooks-based ones in a real-world project. This is because hooks, much like React itself, offers a very adaptive experience. You can use them as much or as little as you need and gradually introduce them into your projects. That said, I would recommend that you get used to using them and employ them as your exclusive tool for building out components in new projects. They're widely adopted by the React community nowadays, and there are countless articles and helpful advice out there on how to build your own hooks and use hooks in general. We'll be exclusively using hooks to power our components throughout this course, so you'll have plenty of experience with them as we make progress through the modules. And for further reading, hooks are amazing and can transform your React development, but they do require a different shift in thinking. I'd highly recommend my fellow author Amelia Wattenberger's excellent article on thinking in hooks, as it offers a unique perspective on how to approach hooks, especially if you're more familiar with React classes. So, Lesson 2, Common Hooks Demoed. Arguably the most common hooks you'll encounter are useState, which is used to interact with a component's state, and useEffect, which can be best thought of as replacing the React lifecycle events, such as component did mount and component did update. Before we move on to our big project in this module though, let's take some time to familiarise ourselves with the use of these two most common built-in hooks. So, project setup. We're going to introduce the Create React app in the next lesson as a great way to build new React projects. For now though, we're going to keep things simple and familiar by using Parcel.js to set up our project and bundle and run our React code for these examples. The first thing to do is to configure Parcel.js. So I've got a brand new folder here open in Visual Studio Code. I'm going to navigate to the terminal window here and initialize our project by running yarn init yes, or with the Y flag. Let's install the packages we need using yarn add react and react DOM. And finally, if we open up our package.json file, let's add the following config so we can call yarn start to run the project. So we'll add the scripts property, and then in here we can add the start command, and this will be very similar to the first demo that we did, parcel index.html, and we'll give that a save. Now our project's set up and ready to run, we need to add the necessary files to our project before we fill them out. So over in the file window here, we're going to add an app.js component. We're going to add index.js, which will be our starting point, index.html, which will be parcel's starting point, styles.css to hold our styling for the two examples, the useEffect example.jsx, which will be our useEffect example component, and then finally our useState example.jsx, which will be our useState example component. useState example and useEffect example are where we'll do the main body of our work here, so let's get the other files set up before we explore our example components. So the first thing is over in index.js here. So over in this index.js file, this will be our main entry point for Parcel to start loading our JavaScript from. We'll import our main app component here and call React DOM's render method to mount it to the HTML element in our index.html file. So I'm going to start by importing React from React and import React DOM from React DOM. Going to import our app component from app, and then finally, as you may remember from the first example that we did, we call the React DOM.render method, and we have to pass it a component or something to mount. So in our case, this will be our app component, and then we have to tell it where to mount it. So this will be document.querySelector, and we're going to do the same thing as we did before. We will give this an ID of output, which we'll find in the index.html file. So that's our index.js file done. So next things next, our app.js component file. So in our app component, the main starting point for our React app, we're going to use a hook here, the useState hook in fact. So let's map this file out. So we're going to import React and the useState hook from React. we're going to import our styles.css file, and then we're going to load our components here. With our imports done, we can define the main component body. So we're going to do an inline export again. So export default props, give it an arrow function, and then we're going to immediately define two variables in the array, destructured array. So this will be example and set example, and then we'll call the use state hook and pass it in a string which will be use state example, and then we'll define our return JSX. So we're going to use the React fragment shortcut again, and then we'll define the rest of the body here. So here we're importing our two example components at the top, use state example and use effect example, and we're using the example value in state to determine which one to show. If example is set to use state example, then we'll show use state example.jsx component, otherwise we'll show the use effect example component. And you can see here we have two buttons as well that both call the set example method from our use state hook, which will in turn change the child component which is displayed. So you can see we're using JavaScript's ternary operator here to basically evaluate if example from use state is equal to use state example by default, then it will render the use state example component, otherwise it will render the use effect example there. And that's our app.js file done. Over in styles.css, much of the styles here are the same basic styles from our very first example that we built in module 2, the greeting app. However, we've added a couple of extra layout selectors at the bottom to add some flexbox support and additional styling to some form elements such as a select and a label. I'm just going to copy this in, but you can find these styles from the course material. And the last file before we move on to our actual example components is the index.html file. Now, once again, our index.html file simply provides us with a basic entry point for Parcel to follow and find our JavaScript starting point. And it's going to look like this. So we'll need a HTML element and a head with a title, and the title hooks example demo. We're going to need the body tag, and then we'll create a div with the ID of output, and then finally we need a script tag which will have a source attribute which will just be our index.js, which is our starting point for the JavaScript in our project. So with the basics file set up and ready to go, let's take a closer look at the use state and use effect hooks. Over in the use state example component, I've just added some quick code to illustrate some talking points about the use state hook. This isn't going to be part of our component. So the use state hook is a direct replacement for the class-based state that you'll see used in this fashion here, where if you want to update state, you will call this.setState and pass it in an object with some properties and some values within that object. And if you want to use the state, you will simply call it with the curly braces and this.state. Whatever the property is. As you've already seen in the previous module, the use state hook has a very simple syntax for setting and retrieving values from it. So if we were going to do this first example here, we're using hooks, we would have this with the initial declaration where we have the destructured array with a pairing of the name of the property in state that you want to set, and then the setting method, which is normally the same name with set on it. And then we call the use state hook, passing in the initial value there. If you want to update this state value, you'd simply call this setting method, so set name of value, and then pass in the new value there. And using it is even simpler. We just call it with the curly braces, then the name of whatever the value is in state. So you're not limited to what you can store inside this state hook, just like you're not limited with state used in a class component. Any valid JavaScript primitive value, array, object, and even function can be passed into and stored in state. So the convention is to have distinct declarations for multiple values, unless they're logically able to be kept together, such as form values. In the first group, you can see that we've got singular values such as an integer, 0, an empty array, and a null value. These are all distinct pieces of state and declared in their own variable pairs, each using a separate call to use state. However, for the form values variable, we're calling use state and passing in an object with multiple properties, one for name, email, and message, that each represent a form field value. We could have easily separated those out into their own use state calls like this too. This is absolutely fine, and you'll see this approach quite frequently. As with a lot of things in development, there's a lot of personal preference and trade-offs and how you tackle a problem and implement a solution. For me, it makes sense to group together closely related slices of data, such as a collection of form field values, into a single place, i.e. the form values variable here. But it does add a little bit more overhead in dealing with updates to any particular form field's value. Conversely, if you have a really large form with a lot of field values, breaking each one into separate call to use useState could potentially create a lot more code for you to manage and a very large component. With that explanation in the bag, let's build a little example app to demonstrate how to use useState and the sorts of values that it can be used with. Let's get rid of everything in this file and make sure you've got useStateExample.jsx open. And the first thing we'll need to do is import React and create the empty component skeleton. So we'll import React, and then we'll just define our component here as an arrow function into a const. And for now, we'll just return the empty fragment, and we'll export by default our useState example. So we want to take a look at how we effectively use the useState hook here. To do that, we're going to build a HTML form that will update values in our component state and display a nice message to our user once they've submitted the form. To do that, we'll need a few things: an object in state to track our state values, a value in state to determine if we should show the message, i.e. has the form been submitted or not, methods to handle changes in the form elements and form submission, and a HTML form. Our component's looking a little bit bare at the moment, so let's fill that out. So the very first thing we'll do is add our state values and items right at the top of the component. So for this, we're going to create two instances of the useState hook. So this one will be show message and set show message. Remember the convention where the name of the item in state is one thing, and then we take that name and just add set to it. So show message and set show message. We call the useState hook here, and we'll give that a Boolean value of false. The next one we'll define will be the one to hold our form values, so we'll simply call it form values and set form values. And for this, we'll call the useState hook and we'll pass in object with 3 key value pairs to represent the 3 form fields that we're going to put into our form. So we'll say name and set that to an empty string, age to an empty string, and fruit also to an empty string. You can see that we really can store just about anything you want into state. Our first state variable show message is going to hold a Boolean value, while our second form value holds an object with some of the default key value pairs in there that we're going to track the input from our user. Now you don't have to add the keys in like we've done here, but I think it's good practice to do so. It'll let you get an idea of what data our form will capture and what the expected type of that data will be without having to run anything. Next, let's map out our state updating methods, our event handlers. One for a change in any form field values and one to handle the form submission. So our first one will be, we'll call handle change. Remember, this is past a synthetic event object, so we'll just call it EVT. And next we'll create our handle submit method, which again will be passed EVT. Remember, you could call that EVT or E or event or whatever you wish, but EVT just makes sense for me. EVT prevent default, and then we'll say set show message to true. So there are a couple of things to notice here. In the handle change event, you can see that we're still using the evt.target.value to retrieve the current value from the underlying HTML element, e.g. a text input field, but we're creating a new updated form values object first. We're using the JavaScript spread syntax here, the 3 dots you can see before form values, which will essentially copy everything from the current form values object in state into our updated form values object. Immediately after this, we use the bracketed notation, passing in evt.target.id to reference a property dynamically on the updated form values object, specifically referencing using the form field's ID. If this exists on the object, then the value we assign to it, e.g. evt.target.value, will be updated. If it doesn't exist, then a new property will be created and assigned to the value of evt.target.value. Finally, we can update our form fields object in state by calling the setFormValues function here. You could do this all in one line, but it's a little neater and more readable to make a copy of the object in state, update that copy, and then supply that method into the updating state. The other thing to point out here is our use of evt.preventDefault in the handleSubmit method. For all the event that React passes us is synthetic, the form submission caused by the button we'll add in a moment is very real. By calling the preventDefault method when the form submits, we'll stop the form from triggering a complete page reload. If that happens, we'll lose our state values and our app will produce unintended results. Other than that, the handleSubmit method is quite simple. We change the value of show method in state to true, which will be used later in our returned JSX. Now we're on to the final piece of the puzzle, which is to add our JSX into the return method so we can actually render something useful to the user. First, a little message introducing the app to the user. And then we will add our React fragment, and add our little message. Next, we can add our HTML form. And there shouldn't be anything too unfamiliar here, just a HTML form. There are a couple of things to highlight though. Notice on our labels that we're using HTML4 instead of the standard for attribute. This is because we're still in JavaScript land, and for is a protected keyword, much like you'd use in a for loop. You can use it, but React will complain, giving warnings in the browser, and any tools like ESLint will also notify you about this. Stick to HTML4 when using an attribute on labels in React. Each of our HTML elements, inputs and select, is setting the value attribute here using a named key from our form value state object. They also each reference the same change event handler, handleChange, here that we defined earlier. Finally, there's no event handler attached to this button within our form. This is because the button will trigger a form submission event by default when it's clicked. So all we need to do is attach our handleSubmit event handler to the form itself. Of course, once we've collected our user data and submitted it, we need to display a little message. So underneath form, we will add show message and then some JSX return if show message is true. Within this, we have a couple of simple paragraphs that we reference the values from state. We also wrap this entire block in a simplified logic expression with this show message and then whatever's in this parenthesis here. What happens here is that JavaScript evaluates the left side of the expression, show message, and if that's false, it doesn't look at the right side of the expression. However, once show message is true, then it would evaluate the right hand side, which will essentially render our JSX block. And that's our useState example component complete. The useEffect hook is a little more complex to understand than its relatively simple useState cousin. React has several lifecycle methods that are triggered during specific parts of component's journey, from being mounted to when it updates, and finally when it unmounts. Before hooks, developers would have to tie updates into these lifecycle methods, tasks such as fetching data, handling updates to props values, cleaning up data handling, or subscriptions to APIs. As we saw in lesson 1, this leads to messy and very complex components. What useEffect gives us is a combined method that runs on each render of a component. It can be used multiple times to separate out any distinct logic, and it can also be passed an array of dependencies which React will monitor for changes. Should any of those dependencies change, only then would that particular useEffect call be executed. Additionally, some work requires a cleanup phase, e.g. subscriptions to external data sources. For these tasks, you can return a function as part of your useEffect call that will carry out any cleanup code you need. You can think of this as replacing the component will unmount lifecycle event. Let's look at the syntax a little closer to get an idea of how it works. So again, over in our useEffect example component, I'm just going to quickly copy in an example here. We've got a simple useEffect declaration, which is we call the function useEffect and we pass it a function. And then you can see we've got some kind of clever data logging service .log function that we pass in an exciting log entry. But this one will be called on each render. On unmount, we might need to clean it up. So you can say on mount and re-render, we can subscribe to this product list. So that's what will be called on mount and on re-render. And we return a function that will be called on render and on unmount. And if we want to use dependencies, then we can use it with this array where we pass in some kind of value, some kind of dependencies, and this useEffect will only be run when props.customer.id changes. So now we know a little more about the useEffect hook, we can build out our component. Empty this out and make sure you've got open your useEffect example.jsx component. Now we'll get the basics component scaffolding in here as well as our React imports. So we're going to import React as well as the use state hook and the use effect hook from React. And we'll define our component. So we const use effect example. And again, we'll do our arrow function and we'll just return the empty React fragment. Default export and give it a save. In this example, we'll be building a really simple gallery that loads everyone's favourite dog pictures. For this, we'll be using the excellent Dog CEO API. For the component, we'll need to accomplish a few things. We need to set our API URL for loading in the pictures. We need to add two variables in state, one for holding the image URLs of our dogs and another loading flag that we can use to show a loading message. We need to create a function to actually go and load our dog pictures. Two use effect calls, one for an initial load and one for subsequent loads when the user presses a button. We need a button for the user to trigger a new set of dog pictures and the gallery itself. So let's get building. The very first thing to do is to define some variables, namely our fixed API URL and some flexible state values. So right inside our component, we create a const that is API base URL, and this will be the URL of the API that we get from the dog.ceo website. Next, we'll use our use state hook to create a variable that will store dog image URLs, which will be an array. And for this, we'll just set it, this initial value as just an empty array. Lastly, we'll create our load pictures flag, which will be a Boolean value set to false initially. Nothing too tricky so far. The dog CEO API address here will return us a single image of a dog. That's no good, so we need to append a random number onto this later so we can get a nice amount of dog images back. With our state variables, dog image URLs is set to an empty array to begin with, but it will hold a list of pictures once the API has been called. With load pictures, we set it to false for now, but we can use this to toggle whether the app is in the middle of loading data or not. Of course, we need to call the API to get the pictures in the first place, so we'll define that next. So we'll create a new function, load dog pictures. So with num to load, we're using the math.random function and we're generating a random number between 1 and 10. Next, we're calling the dog CEO API, appending this random number onto the end to return us that number of doggo pics. And I've used the native browser fetch method here, but in a realistic setting you might need to consider browser support and you might need to look up using a polyfill or external utility library like the Axios project. The process is straightforward. Fetch calls the API, we massage the raw response into JSON, and then we consume that JSON as the object data, extracting a message object defined by the dog CEO API docs, which just happens to be an array of image URLs. We set this array in state using our setDogImageURLs method, returned to us by the useState hook up here. Now to create the useEffect calls. We're going to use the useEffect hook in two separate calls here. One that will be used on initial mount of the component and the other will trigger a new load of pictures when the state value load pictures changes. So let's do our first one. We call the useEffect hook. We pass it in an anonymous arrow function. We're actually using a bit of a React trick here. By passing this useEffect function an empty dependency array, we're effectively telling React to execute the effect but only once on very first mount. We're doing that here because we want to have some dog pictures available when the component first mounts, but not each and every time anything happens, such as when the component updates. We do, however, want to trigger a new fetch when the user clicks the Load More Pictures button. When they do that, the value in state for load pictures will change, and we can have React watch this value and execute our second effect only when that changes. So let's define our second use of the useEffect hook now. So we'll say useEffect. We pass it an anonymous function, set load pictures into the dependency array. So you can see with this useEffect call, we supply load pictures as a dependency to the useEffect hook. When this load pictures value changes, React will execute whatever we supply to the function. In this case, we make sure to check that it is set to true here, calling the API again before setting its value back to false, which will enable the button to work again. The keen-eyed among you will be asking at this point, won't this just trigger the effect to be called again even when load pictures is set back to false? The answer is yes, but by checking to see if it's set to true at the start of the function, we avoid some horrible infinite loop scenario. Now it's time to add the button and the gallery JSX. So with all of our logic in place, we can process the images and display a lovely gallery of our good dogs to our users. Starting with a title, we then add a button that simply sets the load pictures boolean value in state to true. As we discovered when mapping out the useEffects calls, because React is watching this value as a dependency, it will automatically trigger a fetch of some new dog pictures. Under this, we display a message to the user based on the value of load pictures, loading if it's set to true, and the number of dog pictures we can expect to see if false. And the part that we've all been waiting for, the pictures themselves. So we're using the .map function built into JavaScript arrays as we step through our array of dog pictures, outputting an image tag. Notice that we've added an extra attribute you might not be familiar with right away. This key attribute is another React-specific attribute that is needed when rendering a list of things. It helps React keep track of changes within the list, such as if any have been added, removed, etc. You should supply a unique identifier to each item in a list to give the elements a stable identity. The nice thing about the .map function is that if we have an empty array, like when we initialized it to the empty brackets at the beginning of the component, nothing's output to the user. The very last thing to do is to fire up our app using yarn start in the terminal and enjoy some wholesome dog pictures, what the internet was made for. To back over in my terminal, we can run yarn start. And you see we've got a server running at localhost 123. So you should see something like this. So this is our main starting point, and you can see we've already loaded the use state example. And if we type in something here, so we'll call me Rob Kendall, and shockingly, I am 38 years old, and my favourite fruit, we will say, is strawberries. If we submit this, we get a lovely message saying, "Hi Rob Kendall, what a lovely name. I can't believe you're only 38 years old. That's no age." It's really good to hear you say that, React app. Your favourite fruit can't be strawberries, mine too. So you can see this message is dynamically created for us based on the information that we've provided in these boxes. If we say Batman, and if we said that was question mark, and then pairs, you can see that it's updated for us dynamically based on our values in state. And finally, what we've all been waiting for, some pictures of dogs. So we'll click over on the use effect example. And there we go. So we've loaded in 7 pictures, and it's told us that we've got 7 pictures. All happy good boys. And we can click the load more pictures. It'll go off and get us just 2. We click it again, it'll get us a random set, another 7. There we go. Great. So these are 2 good examples of use state and the use effect hooks. Lesson 3, the furry friend gallery. So for our big demo in this module, we'll be building on the previous example, a dog picture gallery, but this time with a few enhancements. Let's take a look at the app to see what we'll be building. So you can see we've got a much improved UI thanks to the Bulma CSS framework. We're accepting a number of dogs to search for from the user. We're displaying the dog pictures in a flexbox grid, and also we're keeping track of how many dogs pictures have been searched for to date. This will also be our first foray into development using the Create React App starter project provided by Facebook themselves. We're not building anything super complex just yet, but there are a few moving parts to consider and some judicious use of both the use state and use effect hooks.